Hello everyone, and welcome back to the AI Research Roundup. I am your host, Alex, and today is May 11th, 2025. Alright, so today we're looking at an ICLR conference paper, Open-YOLO 3D. Towards Fast and Accurate Open Vocabulary 3D Instant Segmentation, published just over 3.5 months ago. This paper introduces Open-YOLO 3D, a novel, efficient way for open vocabulary 3D instant segmentation. This means identifying individual objects and their shapes in 3D, even new ones. Current methods are often slow, using heavy 2D models like Segment Anything or SAM for precise object outlining, and Clip for connecting images with text. Open-YOLO 3D speeds this up using only 2D object detection from multiple views. Alright, so this first figure gives us a great visual. It's showing examples of open vocabulary 3D instant segmentation. You see 3 columns: ground truth, which is essentially the correct ideal segmentation for the scene, then ours, showing the output from Open-YOLO 3D, and finally, a comparison to another method, Open-3DIS. For text prompts like throw the leftover food in the trash bin, Open-YOLO 3D successfully identifies the target object. And importantly, it does this in a zero-shot manner, meaning it can understand and execute these commands for new objects without specific prior training on them. Let's move on to the next part regarding Open-YOLO 3D towards fast and... Okay, so building on that, this next figure, figure 3, dives into a core component called Multi-View Prompt Distribution, or MVP-DIST. This is essentially how the system figures out the correct label for a 3D object. It starts with multiple 2D images, specifically RGBD frames, which capture both color and depth. A 2D open vocabulary object detection model, or 2DOVOD, then processes these frames to create what the paper calls low granularity label maps. These are simplified maps indicating detected objects in each view. From the most relevant views, determined by projecting a 3D object proposal, the multi-view prompt distribution then determines the most probable text label, like chair in the example. Okay, so after seeing how multi-view prompt distribution works, this table, Table 1, really puts things into perspective. It's a state-of-the-art comparison on the ScanNet 200 validation set. We see Open-YOLO 3D listed as ours, achieving a mean average precision, or MAP, which is a key metric for detection accuracy of 24.7, and it processes an entire scene in just 21.8 seconds. This speed is possible because it avoids heavy 2D mask processing, unlike some other methods. This results in better accuracy and a speed up of up to around 16 times, compared to a top method like Open-3DIS. Okay, building on those impressive speed and accuracy numbers, this next table, Table 5, shows comparative results using what are called oracle masks on the ScanNet 200 dataset. Oracle masks essentially mean the system is given perfect, ground truth outlines of the objects, so this test really isolates how well the multi-view prompt distribution component assigns labels. And as you can see, Open-YOLO 3D, listed as ours and using its multi-view prompt distribution, achieves a mean average precision of 39.6, significantly outperforming other methods, especially those relying on clip features. This really highlights the strength of the multi-view prompt distribution approach for accurate open vocabulary labeling. Alright, so after seeing how strong the multi-view prompt distribution is, especially with those ideal oracle masks, this next table, Table 2, takes us to a different testing ground. The replica dataset. This is another state-of-the-art comparison. And once more, Open-YOLO 3D, listed as ours, stands out. It achieves a mean average precision of 23.7, processing a scene in just 16.6 seconds. Importantly, it achieves this without relying on 3D proposals from 2D masks or using SAM for 3D mask labeling, unlike some other methods. This performance really highlights its strong generalization to new datasets while maintaining that speed and accuracy edge. So after seeing its strong performance on datasets like Replica, it's clear Open-YOLO 3D offers a really promising approach. The main takeaway is its significant speed up for open vocabulary 3D instant segmentation. That's identifying and outlining individual 3D objects, even novel ones not seen during training. This speed is achieved by smartly using 2D object detection and the multi-view prompt distribution, avoiding slower, heavy models like Segment Anything or CLIP, which are powerful but computationally intensive image analysis tools. This efficiency is a big step forward for practical applications. Thanks for tuning in to AI Research Roundup.